Yeah, that's for rocking you, babe.
اللهم انبحت عليك ولد غنتلي الشعر شي زهر تاني ونتبدل نجري كل دقيقة كل ساعة ليل وصباح حيت انت مغنى وراسك من الحجر قصاح
اللهم انبعد عليك ولد غنتقلي شهر شي ساعة تاني ونتبدل نجري كل دقيقة كل ساعة ليل وصباح حيت انت مغنى وراسك من الحجر صح. البحر كبير كنت الست يلي
جبل وشاح تاني
غير سرير
البحر كبير
هداك الحب اللي كان زوين قاع ما بقى المقصة جات في الليل وطويل الزنقة يا خلينا غير صحاب ونسيني نصحي الصور اللي فاتوا بينك وبيني
هداك الحب اللي كان مزاون قاع ما بقى المساجات في الليل وطليل الصدقة خلينا غير صحاب ونسيني مسح الصور اللي فاتوا بينك وبيني
غير سنين.
All right, welcome to today's data science webinar on introduction to object-oriented programming. The agenda of today's meeting, if you have, we have rules of engagement, main session, which is going to be led by me, Buhari Shehu, and we'll have the Q&A session, then updates, announcements, and closing. The rules of engagement, if you have any question, you post them on the Q&A, or if they are too technical, you can post them on answer base. The chat will be open for ad hoc interaction with the tutors. Most importantly, listen, learn, and share. Our code for the day is success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. So I want you to react using one of the features. Do you love what you are learning? If that, I need a thumbs up. Else, you can thumbs down. Okay, I see one thumbs up. Okay. So like all those that responded seems they like or they love what you are doing. That's good, which suggests that we are on route to success, right? Then we also have a quick pulse check. How is the sprint going? You can put in the chat Tell me how the sprint is going from your own end. I'm waiting. Oh, I see. Is it sad face from Foba? Okay. Any other response? How is the sprint going? It's fast paced. I can't keep up by Deborah. Okay. Oh, somebody, Joshua is saying Shege. I hope it is not Shege Pro Max. Then Sabilo say it's annoyingly interesting. This interesting. Yeah. Okay. Okay, next up. So please mention any challenges you are facing for those that say it is shaggy and for those that say it is annoyingly interesting. I want you to know. Just mention the challenges you are facing. Okay, I'm waiting in the chat. Waiting, can you mention the challenges you are facing? It seems the participants are not experiencing any challenges, so or they choose not to uncover. Well, always, as always, if you are facing any challenges, you can reach out to us on answer base. Okay, let me see. Like Tabilo is saying, more interpreting the questions to get code for. So his own challenge is on interpretation. I think what you can do, if you don't understand the language you use, you can just copy it and paste it on a chatbot like ChatGPT to explain it for you, or you can reach out to us on answer base. We'll be able to help you decode what it means. Foba is saying unexpected errors like my Git bash not working as expected. Well, yes, I think errors are to be expected, and your ability to work around those errors will make you a better programmer. Yeah, but as always, whenever you hit those errors, you can reach out to your peers on the community, or you can reach out to us on answer base and we'll be able to. Okay, Victor is saying he can't hear me. I don't know if you can't hear me. Can you indicate? I mean, if you can hear me, you can indicate with thumbs up. Else, I'll need to check my network. Okay, I think others can hear me. So, okay, Rokundo is saying the previous code challenge was submitted. However, it does not populate 0% as score. So I think what you can do, reach out to us on answer base and we will be able to help that. Not much intense as, okay. Warrior is saying not much, just an intense contact. Okay. It beats break. Okay. Maybe I will need to change my network during the course of the webinar in order to have a seamless interaction. Oh, I can see some of the learners are experiencing 0%. So please try and reach out to us on answer base so that we can see how we can resolve those issues. So now we dive into the main session. So our learning outcome for today is you should be able to understand and implement object-oriented programming in Python. So what is object-oriented programming? So there are other programming paradigms like the procedural programming, but that's not the focus of our today's discussion. In today's discussion, we are going to focus on object-oriented programming. So OOP is a programming paradigm that organizes software into data structures. So these data structures, they can be called objects, And in this object, you have what we call the attributes and the methods. So and these are some of the things we are going to see, or all of the things we are going to see in this webinar. So what are the advantages of this object-oriented programming? One, it improves modularity. So what do you mean by modularity? Just like Lego blocks, you can, or like the bricks that you use in building your house. So you can shape your house into any shape. But still, when you look at the constraints, they are made up of blocks. So those blocks, the block units, make it to be modular, meaning you can use your block to have any shape or to shape your house into any form that you want. So the modularity that is from OOP, breaking down software into smaller self-contained objects, this improves code organization and maintainability. So when one of the modules is having problem, you can easily track it instead of having one long piece of code, maybe like thousands lines of code that it is going to be very hard for you to trace any issues with the code or to maintain it. Then secondly, we have another advantage, which is reusability. So object-oriented programming, with it, you can reuse some of these codes. So the function that you write in one part of development, one part of your application may be found useful in another part of that application. So with the help of the OOP paradigm, you'll be able to achieve that reusability. So this reusability, we can achieve it through writing functions, and not only functions, through writing classes and through inheritance that we are going to see. So we say by creating classes that can be reused in different parts of a program, developers can save time and effort. So like when we come to regression sprint, you will see that you have different regressors like the random forest and SG boost and the rest of that. So those regressors, if you look at them at the basic level, they are doing almost the same thing. So it is only when it comes to some certain implementation that you have some differences. And through those implementations, so you have what we call the base class, and then you also have the child class that inherits from the base class. So during the demo of this webinar, we are going to see how this reusability can be achieved using what we call inheritance. Then next up is flexibility. So we say OOP allows for the creation of flexible and adaptable software that can easily be extended and modified. All thanks to the classes that we're talking about, you can easily extend your code or your software. And also maintainability. So the encapsulation and inheritance make it easier to understand, modify, and debug your code. So whenever one part of your program is having problem, it's easier for you to just go and pick out that part and repair it than looking at the entire code or the entire module as it is. Like when you're having your automobile, so when your car breaks down, it may be likely maybe the plug is not working or there's no fuel in your car, or one of those components is not working. So it's left for you to just go and trace that what is not working and replace it. So that's the ease of maintainability we are talking about. So what's the structure of OOP? So the whole concept of OOP, it tries to what? To model real-world objects. It tries to model real-world objects like human being or anything, real-world objects and processes into the computing world. So for example, if you want to model yourself inside your computer, so you can use the structure of OOP to achieve that. So looking at any object in this world, it will have two things. one, that object will need a way of describing that object. That way, those things that we use in describing the object, they are the characters of that object or the attributes, right? Just like for those of us that are conversant with the biology class, we have what we call the characteristics of living things. So maybe if you want to model any living organism in the computer, so you use those characteristics as your attribute, right? Then those living things, they are doing some things. So if you look at the characteristics of living things, like some of them are, let's say we can say they are attributes. Some of them, they are what? They are methods. So like reproduction is a method, it's what a living organism can do. But there are also other characteristics of living things that can either be classified as attributes or methods. So methods are what those things can do. Like if we are trying to model the human object into our computer program, we can use attributes like his name, and human being can do things like he can cry, he can laugh. I hope Python is not making you cry. Rather, I want to see Python making you laugh. All right. So what is a class? Yeah. So a class is a blueprint or template for creating objects. So rather than trying to create objects from scratch all the time, you can have a blueprint or a master plan. So like if you want to build your house, what you normally do, you start with the plan or the blueprint of that house. So from that blueprint, you can create your house, and that house you can give it different attributes depending on what you want, right? Then the next thing is objects. So this object is an instance of a class. So an example of a class. So an example of a class is the class of human beings. So human being is a class. Now, out of those human beings, we have different human beings. Like me, the presenter, I'm different. Like some of the Shogun is different, Tabilo is different, and all the participants are different. So we are objects. We are instance of a class called human being. All right, and so like me now, that is an object, I have attributes. One, I have my name, I have my age, I have my address, and all this, my attribute will be stored in my objects, right? A method, I can do things like right now I'm presenting a webinar, and yeah, there are so many other things I can do. All right. So what are the principles of object-oriented programming? Well, so these principles, they are used for building modular, reusable, and maintainable code. So one of those principles is encapsulation. So you put your code, and that's you bind your data and method into one or into a single unit called class. By so doing, you are going to protect your data from outside interference. So what do I mean? For example, you have a bank account. Inside that bank account, you have attribute of that bank account, like the account number, the account name, and the balance inside that account. So all these are attributes, and there are some processes that can be done in that account of yours. One, you can go and deposit money. So that's a method. You can also go and withdraw money and so many other things. You can transfer money or make payments. So now the concept of encapsulation, it will join the attribute, your name, and the things you can do into one. It will bundle them together and call them class. So that is called encapsulation, and it helps us with data security. Then we have what we call the abstraction. So like instead of writing the same piece of code all the time, you hide the implementation complexity and try to use functions like to deposit. maybe from your software, you just click deposit, or to make payments after you enter all the details, or to make transfer after you enter all the details, the next thing you do is just to press a button called transfer. So that button that you press that is called transfer is trying to hide the complexity. So once you press that button, there are so many codes that are brought to life in order to see that your transaction is successful. So that button is hiding the complexity, and we call it abstraction. Then we have the inheritance. So the inheritance allows you to, for example, like during today's demo, we are going to see the car class, and outside, I mean, we have different types of cars. Like you have the electric cars, you have the cars that use gasoline, and you have the self-driving cars. So during the course of this webinar, we are going to see self-driving cars. So this self-driving car is a type of a car. So we are going to have a general general class called a car class. And then outside that, from that car class, we can create subclasses that are going to inherit from this car class. So this subclass that we're going to create is the self-driving car, just like similar to bank accounts. So in bank account, you can have a saving account, you can have a current account. So if you are going to create a software that is going to handle savings account and current account. So what you try to do, first of all, you create current account. You create the account class, then from it, you create savings account, which is going to inherit from your account, and you also create your current account, which is also still going to inherit some of the properties and methods of that account. All right. Then the next up is polymorphism. So this enables, so for example, during inheritance, you may have some methods that you want to modify. For example, in the case of the car, so in self-driving car, in car, one of the methods that you do, or one of the things that you do with your car is braking. So maybe the way you apply brake in self-driving car is different from the way you apply brake in the ordinary car. So how do you modify the brake method of the parent class, the class you are inheriting from, so that it suits your particular need in self-driving class? So we're going to see that during the course of this webinar, which we are going to see shortly. So let's go for the demo. But before we switch to the demo, I don't know if there's any questions. Let me check the chat and see. All right. Okay, let me stop sharing and we'll go to the demo in the absence of questions. Oh, I can see there's one question. Kelvin is saying, are primitive data types also objects in Python? Yes, they are objects. So what do we mean by primitive data types? Like list. So list is a primitive data type, and when you look at it, list is an object because in your list you will have properties or attributes, and not only that, you will have methods that are specific to the list. So with your list, you can have methods like append if you want to add an element to that list and the rest of that. So those methods, if you take them to another object, they may not work. So that's why we call them methods. I hope that answer your question. Else you can still ask if you are not satisfied with this answer. Abstraction. All right. So as we said, so the objective of this is to implement classes, object, attribute, and method. And we should also see how encapsulation, abstraction, inheritance, and polymorphism are implemented. So please confirm, can you see my screen or do I need to magnify it or zoom it? All right. All right, so next up, we are going to see what we call encapsulation and abstraction. So as we said, in your class, you have what? You have attributes and methods. So as we said, attributes, they are the characteristics of the object you are trying to that you are trying to model, and methods, they are those things that that object can do. So right now we say in this, we are going to create a self-driving car in this webinar. So, but before then, we need first of all to create the car class. So I want you to tell me, looking at this car, what are some of the characteristics of this car? I'm waiting for you in the chat. Let me see. How do you describe this car? What are those things that you use in describing them? What are those variables? So I'm waiting for you in the chat. Oh, somebody say number of wheels. Okay. Let's write number of wheels. What again? Can you? Okay, somebody said color. Okay, we can use color. Somebody said tire. So how do you use tire to describe a car? I'm wondering. Somebody said body capacity. Okay. We have different type. Somebody said model. Good one. Somebody said engine type. Somebody said automatic gear, that's the transmission type. I think there are different things we use in classifying our car. So, but for the purpose of this, okay, now, what are some of the methods of this car? What can this car do? Okay, I'm still waiting in the chat. What can your car do? Okay, anyone? Accelerate. Yes, it can accelerate. That is, it can move, or it can increase its motion. And then somebody say reverse. Oh, that's correct. Move forward, that's similar to accelerate. What again? Yes, you can brake. You can turn on the lights. All right. Detect temperature. I think there are so many things we can do with the car. So, right, let's see now, how do we implement this inside our, somebody say blow horn. I think Benjamin said blow horn. Yes, you can. Whenever you notice one abnormality, you can do that. So let's see how we can implement some of these attributes and methods in our class in our car class. So now to implement that, first of all, remember we are going to create a class. So to create a class, you start with the class keyword, and the class we are going to create is the car. Then next up, you start with a method that is going to receive this attribute that we itemize. Thus, it's going to receive this attribute from the user that is trying to define the class or to instantiate the class. Now, to receive your methods, what you are expected to do is to use a function also. I mean, to receive your attributes, you are going to use a function or a method called the .init method. So you say the .init method, and this .init method, I mean def init method, you have underscore, underscore, init, underscore, underscore. Then you open a bracket. After opening the bracket, you start with the self parameter. So in the chat, can you tell me what the self parameter means? So I'm waiting for you in the chat. Can you tell me what the self parameter is? Okay. Somebody says self-driving. No. Self-driving car. No. I think it's better I ask this thing now. This is how you'll have miss it. Yeah. So this remember this. Okay. I think Kelvin is saying. Okay. Let me read what Kelvin is saying. Kelvin says it refers back to the object. Yes, we'll come to see what this self means. So this self is a reference to the object. So you see, after creating this car class, we are going to use it shortly to create what we call objects. So these objects, how do you access them? Through the self parameter. So in this our car, first of all, we are going to collect the brand of the car. That's one of the attributes. Next up, we are going to look at the model of that car. Model, as some of you say. Then we're also going to receive the color. Let me use the American English color. Then after color, what else? Can we collect the speed? Okay, let's leave the speed for now. What else can we collect? From this, we can check the year of the manufacturer. All right. And if we like, we can still collect the speed. So we can leave it out for now. All right, then you close out, then you put your this is then it's next. So after that, the next up you are going to assign. So like all these values, they are called what? Parameters. So these parameters, you are going to assign them to the object. How do you assign them to the object? Remember, we said the self parameter is how we use to refer to the object we are creating. So you start with the self, then you say brand. So the first brand, the self.brand is the object variable. So you assign it to this brand that you are collecting from the user. So I know this may confuse us. Then next up, you say self also, self.model. So this self.model is assigning the object model to the parameter you are collecting from the user, which is called model also. So you do the same for all. To the self.color, you assign color. To the self.year, you assign year. I don't know if there's any confusion here. You can voice out that so that I can take it again. Okay, anonymous attendee is asking, where can I find the weekly webinars? I have checked the portal, but can't find any of the recorded sessions. So I think John will be able to answer this during the later on. Okay, let me see any other questions. Okay, I think there are no questions. Okay, so now looking at this, we can run our class. Remember, we have just collected a portion of this, which is the attributes. We are yet to collect the methods. So looking at this, we can see that we have created the car class. So now how do we access this attribute? Now to access this attribute, first of all, you can start by creating an instance or an object of. So for example, we say each car will have its own name. So let's say the car you are going to create is Toyota. Then we can say Toyota is a type of car. Now we can use the car class. Inside this car class that we created, first of all, we collect the brand. So the brand, we can name it Toyota. Then the model, well, we can have a model called Camry. Then what again? We have the color. Let's have the red color. Then you can have the year. So let's have 2012 as the year. So when we run this, now we have created an instance or an example of a car from the car class, right? And this instance that we just created is the Toyota. All right, so with this, Toyota, we can access the attribute. So we can say, using the dot notation by saying Toyota.brand, well, the brand is Toyota. Another thing, we can check the color of that car of ours. So you can see the color is red. Similarly, we can retrieve the year and the rest of that. So, and what we can do here is maybe we can change the what? We can change the color of our object, maybe from red to blue by this assignment. So we say Toyota.color is equals to blue. So now, next up, when we check Toyota.color, you will see that initially we got red, but now we have the color as blue. All right, so this is how you modify your attribute. So there's a problem with this. And the problem with having a public attribute is sometimes you may have unintended consequences. What are those consequences? They are sometimes called side effects. So this side effect, maybe you have your bank balance as your attribute, and you apply one method to that bank balance. So with this type of arrangement, you can easily modify that value, and that's going to alter the process. So in order to work around this, that's why we have the private attributes. So how does the private attribute look like? Well, to have our private attributes, we can easily modify this. So let me copy that. So if you want to have a simple readable code that you don't want much complexity and you don't want to limit data access, then you can use the public attributes. Else, next up, you use what we call the private attribute. And how does the private attribute differ from the public attribute? Well, just after the dot in the self, you add 2 underscores. You add what? 2 underscores. 2 underscores. 2 underscores. So another thing that you can add here also is the self dot speed Here you can make your speed to be 0. All right. Now, when we run this, our new car class. So now let's try to access this attribute that we accessed the other time. So like using Toyota.color. Okay, let me copy this. But remember, our attribute is having double underscore. So now say this is equal to, we can see it is raising an error. It's not going to show us this. And even when you try to modify it by giving it another color called blue. Oh, I think I need to instantiate this. Okay, I didn't instantiate it. Let me say Toyota 2 is equal to this. Okay, right now, so I can put Toyota 2 is equals to blue. Oh. That was the issue. All right, let's see. Let's copy this. Let's try to access the color. I'm having blue. So what have I done wrong? Because ideally this should not show, just as in the other case that we have. All right, maybe I didn't. Let me give it another name here. Polka 2. So I think maybe I am having issue because the other time I have the same names as my classes. So now when you have your this, you can see that when you do this, it's not going to give you anything. Saying car2 has no attribute this, but looking at car2, we can see that attribute here because the attribute is restricted for us to access. And not only that, you can also not change the color. Oh, why is it changing the color? Okay. I think I'm still having issue with the other one. Okay, let me try to change that of this. Okay, this is equal to, let's say, green. So you can see, or equal to. Oh, I don't know why this issue is this, but ideally what you are not expected to change the color from here. You can only change the color from some method that we are going to create shortly. So how do you access, if from here we cannot access our attribute, how do you access this attribute from the class? So we employ the help of what we call getters and setters to access the attribute of this. So how do you get that? Well, we define a function, we call it get brand. And this brand of the object, which is self, then this will be able to return the self dot double underscore brand for us. All right. So now with this, you'll be able to what? You could be able to now we can define another car called Honda is equal to car 2. Then we pass the brand, which is Honda. The model is Civic. The color is blue, and there is 2018. Then from here, we can use this method, which is called Honda dot get brand. So this should be able to fetch the brand for us. Oh, what's the issue? Didn't I run this? All right. Okay, I think I have indentation issue. Okay. Okay, so now you can see we are able to retrieve our attribute using the get brand attribute. So similarly, you can apply the same what to get the brand, and not only the brand. You can get okay. Okay, I think this one is to set the brand. So another way of modifying the brand is using the set brand. So we define our function def set brand self, then brand. Now we change the self dot brand double underscore brand to be equals to brand, and this should be able to set our brand for us. So let's see how that goes. We run this code, then we run this, then we can always get the brand, which is Honda. Then how do we set the brand? For example, we want to set the brand to, let's say, we want to set the brand. Instead of Honda, we now want, let's say, Benz. Then when you do this and you run your get brand again, you should be able to see that the brand is changed to Benz. All right. So this is how you access or modify private attributes. So you can do the same for this private attribute, the model. So how do we do that? It's the same procedure. You get your what? Get model, and you set also the model. You can do the same for the color. You get the color and you also set the color. And what again, you can do the same for here. I think I'm having this freeze out. Okay. Okay, let me check the question why system is freezing. While it's come back, let me check some of the questions I'm having. Kelvin is saying, will it be syntactically correct to type in color is equals to self.color when defining class attribute? I think to answer this, let's demonstrate whether that will be acceptable. But let's wait for this thing to come back. All right, so let me run this. Let me restart this. Apologies for the technical glitch. Okay. All right, so okay, now so we have this, and I think somebody is asking, can we do it the other way around so that this becomes this? So the problem is, let's try to let's define this. You can see it's giving us error because it is saying two object has no attribute, all this. So that may not work. You can see now it is working because we didn't change the order. So it is not going to be syntactically correct. All right, then after this, we have seen how to retrieve and modify private attributes using the set method and get method, or setter and getter methods. All right, so another thing is that sometimes you can, even though we say these attributes are private, but you can access them using what we call mangling. So in Python, you have you can have what we call mangling. So in mangling, let's have Honda dot. So the class is what, car2, and then we have double dash. Then we say brand. No, you can put equal. I mean, you can run this. Oh, why am I having this? And let's say it's equals to Toyota and see what will happen. So from here, can we have this? Yes, you can see using the mangling, you were able to retrieve your private attributes. But in the ideal case, you use the setter and getters method in order to achieve that. All right, so now remember, all we are doing is to get our attributes. So now how do we model this method like accelerate and brake? So to do that, let's still copy our class. And now after implementing our attributes, next up, we are going to implement our method in our class. So implementing methods like accelerate. So here we say def.accelerate. First of all, this will receive the self, that's the object, then the value. So this value refers to the speed. And next up, we set the speed to the self, and we use plus is equal to value. So the meaning of this is speed plus the value we collected. So instead of that, you can use the shorthand, which is saying plus value. Then your self-driving car, once you accelerate it, or once it autonomously, I mean your car class, once it autonomously accelerate, I'm confusing myself. So the car class, once you accelerate it, what you're expected to see is motion. But in our own case, instead of that motion, we replace it with print. So instead of showing motion, we should display what the car is doing. And how do you display what the car is doing? You put your print statement, then you say self.brand equals, then you enclose it in curly brackets, then self.model. Now you are retrieving the brand, you are also retrieving the model. Remember, while you cannot retrieve this brand and model because they are private from outside the class, but you can retrieve them from within the class. So that's why we are putting self.double_dot model here. Then we put our statement is accelerating, and the speed now is self.speed km/h. So let's run this and try to instantiate. So now we can have, let's have another car. Let's say, which car am I going to use? Let's say Hyundai is equal to my car 2 class, and the model, the brand is Hyundai, the model is Elantra, the color is white, and what? And the year is 2019, all right? So from here, I can say Hyundai. Well, this Hyundai, it can move, it can accelerate. So, and when it accelerates, that's a method. And I can give the value of that acceleration, which is 50 km/h. Although this 50 is not the value for the acceleration. For those of you that know physics, maybe that's the value of the speed. So when I run this, we can see that after giving it this value of speed, it is saying that Hyundai Elantra is accelerating, and the speed is now 50 km/h. So in the real world scenario, instead of having this printed out, this is going to be fed to what we call actuators that are going to translate this into motion. All right. So the next thing that your car can also do is to brake. Maybe you want to stop. So now you create the brake method. And what does the brake does? Well, the brake is going to set the speed to 0. Thus, the car is no longer moving. So we say the brake method. So we define our brake class, which is def.brake.self. Then the self.speed, it will set it to 0. After that, we are going to print what this is doing. So let's run this. So from here, we can instantiate our Hyundai. And next up is to what? Is to stop it. So when you press that brake, what essentially you are doing, you are calling this method from the class, and you see that the message is saying Hyundai Elantra is braking, car has stopped. So also in the real sense or in the real world scenario, this is supposed to translate to the car being stopped rather than having a printout. All right, let me check if there's any question. I take it. Else, we move to what we call inheritance and polymorphism. So now, before we move into inheritance and polymorphism, prior to this, we said this is under what we call encapsulation and abstraction. So what is the encapsulation here? The encapsulation wall is binding these methods, these attributes like the brand, the model, the color, the speed, with methods like accelerate and brake. So when you bind them together to give you a car class, that is called encapsulation. And what is the abstraction? Well, the abstraction now, instead of us to be writing these methods all we need to do is to say Hyundai dot accelerate equals to 50, and we just press enter. And once you do that, your car will just start moving. So that is the abstraction. All right. Okay, anonymous attendee is saying, sorry, but why do we use double underscore instead of one? Yes, so if you use single underscore, the method is no longer going to be private. It is going to be, what is it called? There's a name given to it. Yes, there's a name given to it, but I can't remember the name for now. So when you use single, it's not going to be completely private. And that method is, you could be able to access it. But when you use double underscore, then you may not be able to access it easily. So that's why we do that. All right. Okay. Okay, no questions again. So now let's move on to yes, Sunita, thank you very much. The other name for it, when you use single underscore, it is called protected. Yes, the method is protected. Okay, Kelvin is saying the double dash dot attribute syntax is not strictly enforced in Python as it is in other programming languages like Java. You are right. So that's why I've told you that using mangling, you can still access it. So it is not a strict restriction. The philosophy behind that is that from the Python community, they say we are matured enough that we'll be responsible to treat our data. So that's why it is not strictly enforced. That's the access of 18. Okay. Burhan is saying that I have seen instances where after defining a function, let me see this. I've seen instances where after defining a function, the attributes are in brackets of that function, def self, brand, model, color. Yes, I think that's what we have done here. Okay, I've seen instances after defining a function, the attribute in brackets. Oh, so if you remove this dot init, well, your attributes are not going to be called autonomously when you create this instance. Like when you create an instance called Hyundai, you have your this, and this. Your attributes are not going to be created automatically. So he's saying, does it mean when we use double dash in it, that method, we define them in this method, unlike within the function? Well, the right thing to do is use this if you want to define them in your class. So you have your class, you have car2, You have this, and this ensures that always your attribute is called when we have that. Wario is saying, is the double dash dot init the default method? Yes, we call it the constructor method. So it is a method that I think I have a simple note on it here. So let me read that note for you. So we say in Python, the .init is a special method often called the constructor that is used to initialize objects of a class. It is automatically called when a new instance of the class is created, allowing you to set initial values for the object attributes. So maybe what an exercise that I will encourage you to do is try to create your class without this .init to see whether all the behaviors that we demonstrated today are going to work. I can see Benjamin is raising his hand. You can unmute and ask your question while we switch gears to our polymorphism and inheritance. That's the self-driving car. All right, so a self-driving car is a type of car. So as the self-driving car is, well, in the chat, can you tell me what other feature this self-driving car is having that is not present in our regular cars? In the chat, can I have any of this? Look at it carefully. What else is this car having that is not present in our regular cars? Camera, yes. GPS technology, good. By Mobology. Bruhan is saying camera, yes, the camera. Warrior is saying the sensors, yes. Kelvin is saying the actuators, yes, that's right. So, well, the general term for this, that's the camera, the GPS technology, and the rest of that. The general term for that is the sensor. So you can see your car, when it is self-driving car, it is having addition of sensors. So some of the additional attributes for our car is what? The sensors. So what other things can our car do that? And actuators, of course, actuators. So actuators, there are those things that will make the car move without you matching the accelerator. So what additional methods? So what additional things can the car do without, I mean, that ordinary car cannot do? Can I see that in the chat? Okay. If none is coming, well, I think additional thing that it can do, it can autonomously drive. That is, it can drive itself. That's self-driving. So let's see how we can include this additional attribute to drive to our own class. Yes, and automatic brakes. That's good for you. Automatic brake. And not only that, it can also avoid obstacles. Well, that's part of the autonomous driving. So now, how do we implement our car autonomous car class? So one of the ways you can do is to copy this. You say Control C, then you come here and the inheritance. You say still not having issues. You can come under inheritance. That's you copy your car class since it is addition to it. Then you say paste. So after that, then we can add. Why is it not coming up? Let me refresh. While it is refreshing, can you also tell me what else the car can do that self-driving car can do that other cars cannot do? Or you can ask any questions you are having while it is refreshing. Yes, it can detect obstacle, autonomously recognize traffic signposts, self-parking. All these are correct. So all these are things that your autonomous car can do, which ordinary car cannot do. Okay, somebody say predict shortest or most convenient. Cohort 2 data science learners may one day create autonomous car for us so that we can have what? So that we can demonstrate that yeah, instead of just leaving it to Google and Tesla to do that for us. I trust you can do that because you know these things. So I say one of the things you can do is to what? To copy your car, everything, and bring it here. Then you come and add your additional methods that your car do. So what are those additional methods? We say it can drive autonomously. Then you add your method of driving autonomously. But the problem with this is if you have this and you have another one, then you are going to be repeating code. So what's the best way to go about this? The best way is to use the concept of inheritance. So the concept of inheritance, it will allow you to use all these attributes that are in your parent class and these methods that are in the parent class in your child class, which we are going to have now. All right, so this is not the way to go. Let me clean this up and do the inheritance. So how do you write the inheritance? So to do that, to achieve this, we start with our class. Then we say self driving car. Self-driving car. So the class is self-driving car, but you can see this one, it is having inheritance of car class. So remember, I have modified car 2. So let me put car 2 here instead of having just the car. So it is going to inherit all the attributes and method of the car 2 class. And then also you start with def.init. Then it is going to collect the attributes like the brand, the model, the color, the year, and the sensors, which are additional to this class. Then how do you implement the inheritance? To implement that, you use the super. Then you have your parentheses dot dash dash init dot dash dash. Then you are going to copy all this, the brand, the model, the color, and the year from the parent class. All right, then you use the self.sensors to extend the attributes of the parent class. All right. Then next up, well, you can use what? Your getters to get, in this case, okay, we can privatize our sensors so that we can use our getters to what? To receive what? To receive that's to access this. All right. Then we can also use the setters in order to set the sensors. Maybe those sensors, they can be the camera, that's the light sensor, or the leader. Yeah. So then also another thing we can do, the way you can see here, we're having in the ordinary car, you have your brake, which is manual brake. But in our autonomous car, you are going to have automatic brakes. So now this is where we implement what we call the polymorphism. So this okay, before I implement this polymorphism, let me try to buttress this. So my self-driving car, let me instantiate it. Let me say the Google one is equals to instantiating this self-driving car.google.pixel.black. I mean, it's black, it's 2020, and the sensor is leader and cameras. All right. So I can say this. So now next up, I can access what I can say Google dot get brand. So if you look at this definition of the of this child class, we didn't define any method for getting brand. But you can see here, when you say get brand, we are still able to retrieve the brand of this autonomous vehicle, because in the parent class, we have this get brand method. And another method that we have is the brake. For example, so we can say Google dot get brake, dot brake. All right. So when we run this, we can see Google Pixel is braking, car has stopped. So, but remember, this is the manual brake that we have. What in a situation where you want to modify this brake so that you maintain this same name, but overriding the function of the parent class. So that's where the polymorphism comes in handy. So how do we implement the polymorphism? So to do that, we say, we outright at this, we say def.self, then we use the word super. Remember here, to inherit, we use the super. And here also, to override, to achieve our polymorphism, we use super, then we say dot break. So this is referring to the break in the parent class. So, and we are going to, instead of printing Google Pixel is braking, car has stopped, we are going to say activating automatic braking system. All right, so we can run this. After running this, next up we can, so let me copy this method, this method again to see whether I'm going to arrive at the same value as what is up there. So you can see, okay, what have I done? Oh, should I define it again? Yes, okay. You can see the same. Oh, I don't know. I'm still having this, but you can see the braking is saying activating automatic braking system. So, but the other one at the top is a bug, which I trust you can debug it to see how you can arrest that issue. So I think we are going to stop here because we are able to demonstrate polymorphism, where I use the same name of the function, but using achieving different intended purposes. And we see how inheritance work, and so that you can extend the capability of your code. All right. So next up, we go to the questions and answers session. Okay, let me check. Any additional questions? Okay, I think I've pretty much answered all the questions during the course of the presentation. Burhan is saying continuous learning. I don't know what you're referring to. Maybe you're responding to something I've said. All right. So in the absence of any other questions, we launch the poll. While that is in effect, we can also take the announcements. Oh, Bruhan, yes, thank you. I forgot. I didn't see that. Oh, please, John, can you launch the poll? John, are you there?
Yes, I'm here. Your screen is not loading.
Yes, while I try to refresh it. So while it is refreshing, you can launch the poll so that we can move to the Q&A.
Should I share my screen, Buhari, so that we can quickly go through the announcement?
Oh, you can do that.
Okay,
Yes,
cool.
you can do that, please.
Yes, please. Hi, guys. Hope you guys are doing well. So as I bring the announcement up, please give me a minute also to get your feedback on a few things we want to share with you. So kindly respond to the polls here. The first one will come out as the learning outcome, and then another poll will come out for your employment status feedback, right? So please respond accordingly. So if you have a question too, you can just lift up your hand and unmute and ask your question. Great.
All right, if you are raising your hand, can you unmute and ask your question?
Cool. So I see your responses coming in. That's
Okay.
great. All right. Forgive me, my screen is a bit slow today. Anyway, all right, great. So as you know, we are bringing in a few changes here and there. So please do take note of that. And your code challenge for last week is due today. That is a loops and functions code challenge is due today. I saw a comment in the Q&A concerning you not being able to upload your notebook into the autograder, right? Please note that this concern has come to us and the team has currently escalated that, and our technical team is working to resolve that. So we'll share an update on that very soon, right? All right, cool. And then also, you know that you still have multiple attempts. So if you are not affected by this technical glitch, please do go ahead and submit your code challenge. And then you have a multiple attempt to score the 100% score. So use it wisely and make sure you get the pass mark. And as you know, you only have one supplementary attempt, right? That is after the deadline. So take note of that also. And we did share an update, and please note that we'll be sharing more updates concerning our changes coming up. and forgive us for the a lot of changes coming up because we want to give you a better experience. So next week, webinar for Monday will be hosted on Wednesday, and then our webinar for Wednesday will be hosted on on Friday, the same time, right? That's the 12:30 p.m. GMT, right? The same time. That's what's going to happen. And one thing you need to notice is that we are going to share a form with you, I think very soon, by Wednesday, it should be out, just to let us know which day you feel will work best for you, for us to host these sessions, right? So look out for that form that will be coming out to you. Please engage to share your feedback with us. Let's give you the best experience as we can. And our next webinar session will happen this Wednesday. That's 2 days from now. And that will be on exploring the powers of Python models, right? So you wouldn't want to miss that. We are going to get deep into the powers of Python models. So book a date and join us for that session. And if you are still having issues with answer base, please do send a ticket to Zendex, or you can message me on the portal and we will try and help you out on that. I saw a comment about where to find the recordings of the sessions. I'm sure everyone should know that, but if you are struggling, please jump onto the portal. And once you're on the portal, look for data science resources, right? Once you see data science resources, you click on it. Once you enter there, you will see webinar recordings, right? Once you see the webinar recordings, you click on it, you will see all recordings from the beginning of this program till date, along with the various slides and notebooks that you need and other details that you may need. They are all there for you. So please utilize it accordingly. Great. On that note, you know how to answer base for your technical support, Leah Zendex for support from our team, and then ALX Fellowship for our day-to-day communication, right? Cool. I see Gallo. I'm not sure if you are ready to respond to to ask question, but if yes, then I'm going to give you permission to do so. And in the next 3 seconds. If not, then we will say a goodbye to you guys and catch you. Okay, go ahead, Gallo. Yeah, hello, Gallo. You can go ahead and ask your question.
Hear me?
Yes, can hear you.
Yeah. My question is on the submission of the code challenges. From the announcement, it has been indicated that there's only one supplementary attempt. What if someone fails to score above 50 in that supplementary attempt? Does it mean that he or she will be dropped out of the program, or what will be the consequence?
Buhari Shegun would want to take this.
All right, I can take it. Gallo, can you come again the last part of the question? Let me be clear.
Yeah. I was saying, if one fails the supplementary attempt, will he or she be dropped out of the program, or what will be the consequence of that?
All right, thank you very much. So if you fail the supplementary attempt, and this is advice to everybody across all the MCQs, if there's any MCQ aside from the coding challenge that you did not get 50% mark with the supplementary, ensure you do the practice test and score above 50%. It is very important. So if you cannot make the 50% mark with the supplementary, ensure you get the more than 50% with the practice tests. I hope that's clear.
Yeah, thank you.
Yeah, thank you very much.
All right, cool. On that note, see you all on Wednesday, and please stay tuned for updates that will come with the changes of the webinar. All right, bye guys.
yeah.